Hello everyone, my name is Vanessa Lagos and I am a first-year PhD student in the 5 years PhD program at the Division of Nutritional Sciences under Dr. Hans Stein. Today, it is my pleasure to talk about chemical composition and amino acid digestibility in soybean meal produced in the United States, China, Argentina, Brazil, or India. This is the outline of the presentation. I will start with a brief introduction. I will explain the material and methods used in the experiment. I will show the results and I'll discuss them, and by the end, I will give you some conclusions. Soybean meal is the premier source of amino acids in growing, finishing, and reproducing pigs. However, as is the case for all feed ingredients, variability in the nutritional value has been detected among different sources of soybean meal. Differences in the growing area, soil type, climatic conditions, as well as differences among varieties of soybeans or in processing conditions may contribute to variability in the nutritional value of soybean meal. These variations also cause variability in the digestibility of nutrients, resulting in lack of accuracy predicting the nutritional value of diets. This map shows the top 10 soybean producing countries. However, we chose these 5 countries because more than 85% of soybean production is concentrated in these places: United States, Brazil, Argentina, China, and India. Likewise, these countries are the 3 major soybean exporting countries. Therefore, the variability is important in places where soybean meal is imported, primarily the European Union and Asia. These places have choice, which means the differences in the nutritional value of soybean meal matter. In previous research, the digestibility of amino acids in soybean meal from different countries has been compared. There is information about the SID of amino acids when compared soybean meal from the US and soybean meal from other countries. The authors concluded that there is less SID in soybean meal from Argentina and Brazil than in soybean meal from the US. Likewise, there is information about the variability of the SID of amino acids among and within countries in soybean meal from Argentina, Brazil, and the US when fed to piglets. The authors concluded that there is greater SID in soybean meal from the US than in soybean meal from Argentina, and that there is homogeneity among sources of soybean meal from the US. Regarding the variability within countries, there is information about the differences in soybean meal from 3 different zones of the US. However, just few differences in the SID of amino acids among sources of soybean meal were detected. However, despite the information available, there is no information about the variability of the SID of amino acids in soybean meal from the 5 major soybean producing countries. Therefore, the objectives of this experiment were to determine if the SID of amino acids in soybean meal from 5 different countries is dependent on the country where soybean meal was produced. The second objective was to determine if there are differences in the SID of amino acids in soybean meal within countries. Now let's move to the material and methods. For the sample collection, 5 sources of soybean meal from the United States, Brazil, Argentina, and China, and just 4 sources of soybean meal from India were collected. Sources of soybean meal from the United States, China, and India were collected in those countries. However, soybean meal from Brazil and Argentina were collected in feed mills located in the Philippines, South Korea, Spain, and Denmark. Regarding the 5 sources of soybean meal from the US, they were collected in crushing plants from South Dakota, Iowa, Illinois, Indiana, and Ohio. 25 cannulated pigs with a body weight of 30.5 kilograms were allotted to 25 diets and 8 periods. Therefore, there were 8 replicates per diet. 24 cornstarch-based diets with the inclusion of each source of soybean meal, and 1 nitrogen-free diet to estimate the endogenous losses were prepared. The experimental procedure and the calculations follow protocol already established in previous research. Now let's check the results, and let's start with the nutrient composition. This is the concentration of gross energy and crude protein in soybean meal from different countries. For now on, the orange bar represents soybean meal from Argentina. The blue bar represents soybean meal from Brazil. The yellow bar represents soybean meal from China. The purple bar represents soybean meal from India, and the green bar represents soybean meal from the US. There is a greater concentration of gross energy in soybean meal from Brazil than in soybean meal from the other 4 countries. In terms of crude protein, there is a greater concentration of CP in soybean meal from Brazil and India than in soybean meal from Argentina, China, and the US. For most amino acids, the concentration followed the same pattern as crude protein. Regarding the 4 limiting amino acids, soybean meal from China had a low concentration of lysine, threonine, and tryptophan compared with soybean meal from Brazil, India, and the US. Regarding the concentration of fiber, there is a greater concentration of ADF in soybean meal from China and India than in soybean meal from Argentina and the US. Likewise, there is a tendency in soybean meal from India to have greater concentration of NDF than soybean meal from Argentina and the US. This high concentration of fiber may be a consequence of the addition of hulls back to soybean meal. The lysine-CP ratio in soybean meal from all countries was higher than 6. It was already stated in previous research that values above 6 indicate no overprocessing or heat damage. However, soybean meal from the US had the greatest lysine to CP ratio. For trypsin inhibitors, soybean meal from all countries except India had a value below 4. It was already demonstrated that values lower than 4 indicate no underprocessing in soybean meal. Now, let's check the results of the digestibility among countries. The SID of CP in soybean meal from the US was greater than in soybean meal from other countries. However, there were no differences between soybean meal from China and soybean meal from the US in terms of the SID of indispensable and dispensable amino acids. With this slide, we can observe that there is no relation between the concentration of crude protein and the SID of crude protein and amino acids. Soybean meal from China has a high SID of crude protein and amino acids, but also has a low concentration of crude protein. For these 4 limiting amino acids, the SID follows the same pattern as for all indispensable amino acids. There are no differences between soybean meal from China and soybean meal from the US in the SID of lysine, methionine, threonine, and tryptophan. The lower SID of amino acids in soybean meal from India than in soybean meal from the US may be a consequence of the higher concentration of fiber and trypsin inhibitors in soybean meal from India than in soybean meal from the US. Now that we have the concentration of amino acids and the SID of amino acids, we can calculate the standardized ileal digestible amino acids in grams per kilograms. There is a greater concentration in soybean meal from India and soybean meal from the US than in soybean meal from Argentina and China in terms of lysine, threonine, and methionine. However, despite of the lack of differences between soybean meal from China and soybean meal from the US, there is a lower concentration of standardized ileal digestible amino acids in soybean meal from China than in soybean meal from the US. This pattern can be observed in all 4 amino acids. This is a result of the low concentration of crude protein and amino acids in soybean meal from China than in soybean meal from the US. This means we have to keep in mind both the concentration of amino acids and the SID of amino acids to have a better estimate of the protein value. Now, let's review the results of the digestibility within countries. This means we are going to compare all 4 or 5 sources of soybean meal within each country. Let's start with Argentina. For this slide and following slides, the orange bar represents source 1, the blue bar represents source 2, the yellow bar represents source 3, the purple bar represents source 4, and the green bar represents source 5. For most amino acids, there are differences among sources of soybean meal from Argentina. This means that if we are going to buy soybean meal from Argentina, we can obtain soybean meal with values of SID of lysine above 90, but also we can obtain sources with values of SID of lysine below 90. Whereas in soybean meal from the US, only for lysine we found differences among sources. However, for all sources of soybean meal, the SID values of lysine were above 90. In the 4 sources of soybean meal from India, there were differences in some amino acids as threonine and tryptophan, but we also didn't find differences for some other amino acids as lysine and methionine. For the 5 sources of soybean meal from China and Brazil, we did not find any differences among sources. With this experiment, we can conclude that soybean meal from Brazil and India have the greatest concentration of crude protein and amino acids, and soybean meal from China had the lowest. There is a greater SID of most amino acids in soybean meal from the US and soybean meal from China. However, less concentration of standardized ileal digestible amino acids in soybean meal from China than in soybean meal from the US was observed. And there is less variability among sources in soybean meal from the US, China, and Brazil than in soybean meal from Argentina and India. With this, I want to thank Indiana Soybean Alliance and the US Soybean Export Council for the funding and all people from the lab for their support. And if you want to learn about this topic or other topics, you can visit our website nutrition.ansai.illinois.edu.